And welcome to the final video of this chapter. The next group of problems says use a calculator to solve the equation and round the solutions to 2 decimal places if necessary. Well, they will be necessary. And realize that we're going to be quite different than how we looked at in the last section. So let's begin with problem number 11. Once again, there's no way for me to show this on this particular video, and so you'll just need to listen to what I say and then go from there. Here we have a problem. We have both an x and we have the sign of x, or x and the function of x, and stuff like that. So what we're going to have to do is we're going to have to realize that this is going to have to be done the brute force method. Well, with the advent of a graphing calculator, it makes it very, very simple. First thing we're going to do, solve for, or get everything to one side and 0 on the other. So it's x plus 3 sine of x minus 1 equals 0. Then what we need to do is we need to graph this. We're going to graph x plus 3 sine x minus 1, and we're going to look for what are the x-intercepts. And after we do that, there is only one x-intercept on this whole graph, and that is at the point 0.25. And so you'll need to know how to find the x-intercepts on your graphing calculator. What's very important to realize is you must get everything to one side and set it equal to 0. But once you do that, just graph this and find the x-intercepts, and that will be your answer. Number 12 is x squared minus 4 cosine of x equals 0. And once again, same thing here. Get everything to one side, set it equal to 0. It's already there, so all we have to do is punch this into our graphing calculator. Y equals x squared minus 4 cosine x. We're going to find the x-intercepts, and there happen to be 2 of them here. And they are negative 1.20 and a positive 1.20. Example 13. 2x squared minus 3x sine x equals 2. Okay, once again, we have to solve for, or get everything to one side, because we have both an x. We actually have an x squared, an x, and a sine of x. There's just no way we could solve this algebraically. So what we're going to do is we're going to get everything to one side by subtracting 2. And then we're going to graph this. Y equals 2x squared minus 3x sine x minus 2, and find the x-intercepts, and those x-intercepts occur at negative 1.93 and a positive 1.93. 14 through 16 actually ask us to use a graphing utility to solve the equation on the interval 0 degrees to 360 degrees. So one of the first things we're going to have to do is to change our calculator into the stupid mode. And then we're going to express the solutions rounded to 1 decimal place only. And so 14 through 16 is really a continuation of 11 through 13. So number 14 will be 2 plus 13 sine x equals 14 cosine squared x. We need to get everything to one side and set equal to 0. Although, well, yeah. And so what I will do is I will subtract 13 sine x and subtract 2. So I get 14 cosine squared x minus 13 sine x minus 2 equals 0. After I make sure that I am in degree mode, I will punch this into my calculator and say y equals 14 cosine squared x minus 13 sine x minus 2. Be very careful when you put in the cosine squared as part of the graph. You will actually put the cosine of x inside an entire set of parentheses and then square that whole thing there. And after you do that and you find the x-intercepts, you'll find that those x-intercepts occur at 34.8 and at 145.2 degrees, because we are in the stupid mode. The final two examples of this section, which will complete the entire chapter. Number 15 is sine squared of x minus 8 sine of x minus 4 equals 0. We've already got it solved for 0, or set equal to 0, so all we have to do is punch this into our calculator. Y equals sine squared x. Remember how to punch in the squared functions. Minus 8 sine of x minus 4. When we do that and we find the x-intercepts, we find that x is equal to 208.2 degrees as well as 331.8 degrees. And then finally, number 16. 7 cotangent squared of x minus 5 equals 0. The only additional thing that I really need to talk about here is the fact that we've got cotangent. So just make sure that you would do 7 times 1 over tangent and then be sure to square that whole mess. Minus 5 equals 0. But it does, since tangent and cotangent have a period of pi, it's potentially going to give us more answers, and in fact it does. And if you look at the graph, it's going to cross the x-intercept, or it's going to cross the x-axis at 4 different locations between 0 and 360 degrees. And so we need to find each and every one of those. And so that would be at 49.8 degrees, again at 130.2 degrees. Then this should not be a big surprise, 229.8 degrees. It's just pi bigger than this, or 180 degrees bigger than this, and likewise the 180 degrees bigger than that would be 310.2 degrees. These last two should not be surprises once we get these first two, because we know it's going to occur every pi thereafter. So this completes this particular section.